Good morning. Warm-up should be done. Did we get an answer for the first one?
5.
Okay, 5. You guys can call it out. 5. Do you agree?
Yeah.
Okay, how did we do that? Did we expand the top, expand the bottom, and then simplify, or did we do something else? What's your name up front? Sorry. Okay. Good, right? So there's a rule that we're going to talk about today that you can subtract the exponents. And when you do that, you get 5 to the power of 1, which is just 5. I'll explain why that rule works a little bit later, but that's what we should get for that one. All right, did we get an answer for number 2? If you did, call it out.
5 to the power of 1.
Okay, so we should get 5 to the, we can do the same rule that we did yesterday, right? Something like this was on your homework last night. A lot of people had questions on it. All you have to do is add the exponents, right? You're not going to do anything with the base. You don't touch that at all. So this is going to be 2 plus the next exponent plus the next exponent. And then when you do that, x minus x cancels out. 2 plus 3 minus 1 is going to get you 4, so we get 5 to the power of 4, which is, like some of you said, 625. Are we okay with that, guys? All right, good. So then the next one is, what do we do here? What can we do with that 3? You were saying?
Yeah, you just multiply.
Okay, so you can distribute this exponent to each factor on the top and on the bottom. So we get 9 to the third x to the third over 7 to the power of 3. All right, 9 to the power of 3 should get you 729. X to the power of 3 over 7 to the power of 3 should get you 343. All right, are we good with our warm-up? Any questions at all? No, shouldn't be too bad, right? So in a second, we're going to get started. Okay, so while you guys are pulling this up, I'll just go over this slide. Our rule for today, our rule of exponents for today are going to be negative exponents and then dividing with exponents. So if you have a negative exponent, it just moves whatever the base is from the numerator to the denominator or vice versa. So that's expressed here. For example, a to the negative n is the same as 1 over a to the power of n. Similarly, 1 over a to the negative n, right? This just moves back on top and it just becomes a to the n. All right. An example could be like x to the negative 2, right? You don't see a fraction. How can you make anything a fraction? Good, right? Putting it over 1. And so now that it's over 1, you can clearly see, okay, I need to move this to the bottom and make this positive. And then this is going to turn into 1 over x to the positive 2. All right. Now, when you're dividing with exponents, this showed up in your warm-up, although you didn't have to do it this way. When you're dividing expressions with the same base, you subtract the exponents. All right, so for instance, a to the power of m over a to the power of n is the same as a to the m over minus n, sorry. All right, I'll show you with our example this morning, 5 to the third over 5 to the second. The reason this works is because we know that 5 to the third is the same as what? 5 times 5, right? And how can you write 5 to the power of 2? Just 5 times 5, right? How many 5s do they share in common? The top and the bottom. 2, right? So you can cross out one set of factors, 2 sets of factors, and you're only left with 1 5 on top. That's why it works. You're not going to show it like that every time. Just wanted to show you where it comes from.
Can you explain the first part again?
Which one?
The one with like the a negative n.
The negative exponents?
Yeah.
Like the rule itself, or do you want to know why it works?
I just not really understand it.
It just switches its position, right? So if I had 1 over x to the negative 3, is it in the top or is it in the bottom? It's in the bottom. Negative exponents, for our sake, for the sake of this class, are not simplified, so you need to make it positive. The only way to make it positive is to switch its position. So if it's on the bottom, move it to the top. Then this becomes x to the power of 3. All right? Good with this slide, guys? Mm-hmm.
You do that no matter what's on the numerator?
Yeah, so that's a good question. Let's say it was, I don't know, I had a 3 on top. 3 over y to the negative 5. 3 is fine the way it is, right? You guys agree there's no negative exponents on top? But this negative 5 is not simplified. It's on the bottom, so you need to move it to the top, right? So we're going to move this to the top, and this is going to become 3y to the power of 5. The 3 you don't touch.
So the denominator will always be 1 after you do this?
Yeah, it's always, yeah, if you want to maintain the fraction, right? It's going to be over 1, but you don't need to write over 1. It's going to simplify to 3y to the 5th. Similarly, if you had something on the bottom already, let's say it was y to the negative 4 over x to the power of 2. All right, what's our issue here? What's making this not simplified? The negative 4, right? Where is it? Top or bottom? The top, so you need to move it to the bottom, right? This is going to move to the bottom, and you need to make that a positive. What's left on top after you do that? A 1, right? If we keep that as a placeholder. And then x squared is fine the way it is. We don't touch that, but then this becomes y to the positive 4. Sorry, it's kind of tight. But
So you don't swap them, like you just put them like with whatever?
no, you don't swap it. Don't swap it. That's why I'm being careful with my words. I used to say switch it, but then if you see something on the bottom, a lot of kids interpret that as you have to like switch both of them. You just switch whatever has the negative exponent. All right, good so far. Ready to start some examples? Okay, good. All right, let's start pretty simple. Right, we have 4 to the negative 2. All right, not simplified because of the negative exponent. What do we have to do? Okay, so we're going to write this over 1, right, to make it a fraction. And then what we have to do is move this from the top to the bottom. This is going to become now 1 over 4 to the positive 2. We can simplify that more, right?
1 over 16.
Good. So we get 1 over 16. Not bad. Similarly, if I had x to the negative 3, not simplified, and it's not already a fraction, so if you want to make it a fraction, you're going to write over 1. Negative 3, we're going to make positive by moving it to the bottom. It's on top, so you want to move it to the bottom. This is going to become 1 over x to the positive 3. All right. The next example is kind of what we were just talking about. What is the base here that has the negative exponent? Is it 2x or is it just x? Okay, how do you know it's just x and not 2x? What don't you see? Parentheses, right? If you don't see parentheses, then you cannot assume that it's both of them, like this. All right, so we're just going to do it to the x. So I can still write over 1, and we're just moving this to the bottom. So what's on top then? 2. What's on the bottom now? X to the power of 4. Nice, guys. All right. So far, so good? Pretty easy? Good. Okay. We can do something similar here. Although what's different about this one? It's a fraction and it's parentheses, right? But what did we talk about yesterday with dividing and multiplying? If there's an exponent over, where can this go? Like, what does this apply to? The top and the bottom. Good, we're going to apply it to the top and the bottom. So this is going to become 2 to the negative 3 over 5 to the negative 3. Now you can switch them, right? Because they both have negative exponents. Neither the top nor the bottom are simplified. Since these both have negative exponents, this is going to move to the top. And this is going to move to the bottom. So the 5 to the negative 3 that was on the bottom is now going to be on top. The 2 to the negative 3 that was on top is now going to be on the bottom. Mm-hmm.
So if both are negative, you have to swap it?
Yeah.
Okay.
You can simplify that more, right? What's the top? What's the bottom? 8. Nice. Bless you. Good, not bad. All right, what about the next one? What are we doing here? Okay, it's not a fraction, so I'm going to write over 1, and then what's moving to the bottom? 4 or negative 4?
4.
Negative 4, right? Do we see why this one's negative 4? Yeah, the parentheses. This entire thing is being raised to the power of negative 2, so I'm moving this entire thing to the bottom. So then this is going to be 1 over negative 4 to the positive 2. And then what's that on the bottom? 1 over 16, right? Negative 4 squared is just 16. All right, how's the next one different? There's no parentheses. Do you guys remember yesterday the controversy with the parentheses and no parentheses? So what's our base here? Is it 4 or is it negative 4? Our base is just 4. So if I write this over 1, what's moving to the bottom? Just the 4 to the power of 2. What's going to stay on top? We can treat that as a negative 1 as a placeholder. This is going to be negative 1 over 4 to the power of 2. So negative 1 over 16. All right, big difference that a parentheses makes. All right, that's our first page. Pretty easy. Good. Let me zoom out so you guys can see everything. Moving along. Let's look at this one now. Okay, we have more things going on here, but nothing too crazy. All right, what's going to switch positions here? Just the y. Do we see why it's just the y?
Yeah.
Good, because this negative 3 is only over the y. So this is going to move to the bottom. X is going to stay on top. And then it's going to be good. Y to the positive 3. Good. All right, let's do 9 now. I'm going to do 8 and 10 together. All right, but let's do 9 now. All right, more things going on, but still the exact same concepts. We're going to take it one at a time. Question?
So,
all right, if you look at the 4, is there anything over that 4? No, right? So that's going to stay on top. X to the negative 3, can we move that? Yeah, right, this is going to move to the bottom, so I know that that's going to become x to the positive 3. Y to the second, is there anything wrong with that? No, so we can keep it the same thing. Z to the 4, is there anything wrong with that? Yeah, right, that negative 4 we can move to the bottom. This is going to become z to the positive 4. Good morning. All right. 8 and 10, like I said, we'll do together. All right, we got some coefficients on the top and on the bottom. Just like with multiplying, you're doing coefficient with a coefficient, x with the x. Can we do anything with 4 and 16? Okay, 4 over 16, how does that simplify? Good, they share a factor of 4. This is going to be 1 over 4. And then x to the third over x to the fourth, how do we handle that? Okay, good. So you can subtract the exponents. This is going to be x to the 3 minus 4. And this is 1 over 4. This is still x to the negative 1. All right, now what's wrong with this? Good, there's a negative exponent, so you're going to move this to the bottom. This is going to become 1 over 4 x to the positive 1. Do you need to write an exponent if it's 1? No, so you can just get rid of it. If you do write the 1, I don't care. Question?
I have a question. So, because there was an x on the top and on the bottom, why did you default to the numerator? Did you just default to the numerator?
You always default to the numerator if you're subtracting.
was this the same? You put subtracting?
Since this x matches this x, you subtract and you're always going to keep it on top. You always assume it's on top unless it's a negative exponent, and then you can move it. All right, good with that one? Good, we can try the same thing here, right? Coefficient with a coefficient. Our coefficients are just 3. So does that need to do anything? No, we can just keep it, right? And then we have x with the x. We're going to do x to the negative 2 over x to the 4. How do we handle that?
Minus 2 plus 4? Or minus 4?
Okay, good. So you're going to subtract the exponents. So top minus the bottom. So it's going to be negative 2 minus 4. We'll worry about that in a second. And then what do we do with the y's? We're going to do y with the y.
We're gonna
You're still going to subtract, but because it's minus a negative, it's add, right? So that's when you do add. So it's going to be 4 minus negative 3. Some of you guys might get it right away, but I'm writing every step. All right, so this is what we have so far. And right now, this is over 1, right? There's nothing on the bottom left. But let's simplify everything. We get 3x to the negative 6, y to the positive 7, right? And then what can we move to the bottom now? The x to the negative 6 is going to move to the bottom. This is going to become 3 y to the 7th. You don't touch those. This is going to be x to the 6 on the bottom. All right, so as they get more complicated, no big deal. Take it piece by piece. All right, are you okay with that one? Mm-hmm. Yeah. All right, we'll do a bunch more over here. This one, we're just applying the same rules as before. So I have 5 to the power of 9 over 5 to the power of 7. What can we do here? Okay, subtract the exponents. This is going to become 5 to the 9 minus 7. So what? 5 to the power of 2, so 25. Nice. Now let's try 14 now. I'm going to do 12 and 13 together. How do we do 14? Okay, yeah, there's a couple ways that you could go about it. I heard that one first, so I'm going to do that. You see the negative exponent, you might want to move it to the top first. There's nothing wrong with that. Then this becomes 7 to the power of 5 times 7 to the positive 3. Now, what was our rule for multiplying? What can we do here? Add the exponents. This is going to become 5 plus 3, so 7 to the power of 8. It's going to get you a really big number. I'm fine if you just leave it like that.
On the test or quiz, we want to solve it all the way?
I'll be more specific when we get there. We haven't made the quiz yet. But if I'm sure that there's going to be a huge number on there or anything like that. Or even if there isn't, I'll tell you guys ahead of time the threshold, like maybe 5 and above, you don't have to do. Anything up to 4, I think, is a pretty safe bet. But don't worry about that right now. We're not there yet. Another way that you could do it is maybe you see the fraction right away and you want to subtract it. That's also perfectly fine. You get 7 to the 5 minus negative 3. And then that's going to get you plus, which is still 7 to the 8. So no matter how you look at it, you should get the same answer. All right. Let's do 12 and 13 now. What's the difference between these two? Okay, they're switched, right? It looks like they're switched. Let's see how that has an effect on the answer. Let's do number 12. Same as always. This is going to be x to the what? To the 4, right? 14 minus 10. Nothing's wrong with that, so I just leave it alone. All right, now let's look at 13. Same exact idea. This is going to be x to the what? To the negative 4, right? Is that simplified? No, we're going to write this over 1, and we're going to move it to the bottom. This is going to be 1 over x to the positive 4. General rule of thumb, if you have the same exponent on the top and on the bottom, whichever one has the bigger exponent is where you can expect to find the final answer. All right, so in this case, 14 was bigger than 10, and 14 is on the bottom. You can expect there to be an x on the bottom. The reverse is true for this one. 14 is bigger than 10. It was on the top. You can expect it to be in the numerator. All right. Let's try something similar here. Actually, these you can try on your own. So take a minute, do it on your own first. So let me show the work really quick. Guys. Focus. We're almost done. 15 and 5, we're going to do coefficient with the coefficient is 3 over 1. x to the negative 4, x to the negative 8. Couple ways you could do it. You could switch the position first, if that's what you want to do. Or what you can do is right away subtract the exponents. I'm going to switch the position first. Maybe you did it differently. That's perfectly fine. I'm going to switch the negative exponents. So this is now x to the positive 8, x to the positive 4. And now I can see that this is 3x to the 8 minus 4 over 1. And 8 minus 4 is just positive 4. So this is 3x to the positive 4 over 1, which you don't need to write the over 1. So it's just 3x to the positive 4. All right, good with that one? Okay. Something similar with the next one, 15 and 25. Share factors of 5, so it's going to be 3 over 5. I'm going to do this one the other way. I'm going to subtract right away. Why not? All right, so this is a to the negative 5 minus negative 2, which is plus 2. We get b to the negative 1 minus 4. And then this is going to become 3a to the negative 3, b to the negative 5 over 5. We can't leave it like that because there are negative exponents, so I'm going to move whatever has a negative exponent to the bottom. This is going to get you 3 on the top, nothing left, and then it's going to be 5a to the third, b to the fifth. Good with that, guys? Okay, not bad. Let me zoom out. Okay. Last two examples. All right, there's a lot going on here. You're going to do it one at a time. Don't try to rush it. Don't try to do everything at once. You're probably overwhelmed with the rules that we have to do here. But do it piece by piece. I personally like to see if there's anything inside the parentheses that I can simplify first. Is there? There is. All right, we can't do anything with the negative 3 and the 4, but I see a's. I see multiple a's. So that's going to become what? A to the, what rule can I apply here? Okay, so this is going to be, okay, a to the first. You could move the negative to the top. Yeah, I'm going to do that. Why not? I'm going to move the negative 3 to the top. So this is a to the first times a to the positive 3. And then the b's, they're both positive, but we're dividing. So if we're dividing, what can we do? Subtract the exponents. So this is b to the 1 minus 4. And then I still have this whole thing over a negative 2. Take your time. Don't rush it. I'm going to take my time to simplify the top. This is negative 3a to the 4th, b to the negative 3, over 4 to the negative 2. Are we okay with how I got from here to here? Yeah, good. Okay. What else can I do to simplify the inside of the parentheses? Good, so this is going to become negative 3a to the 4th over 4b to the positive 3. And this is all to the power of negative 2. Is there anything left inside that we have to do? No. But that made it look a little bit simpler. A little bit, all right? Not too much simpler, but a little bit. Now let's take what we learned yesterday. What can we do with that exponent on the outside? Distribute it to each factor on top and on the bottom. So this is going to go to this, that, this, and that. So then we get negative 3 to the power of negative 2, a to the 4th to the negative 2, over 4 to the negative 2, b to the 3 to the negative 2. So we have a whole bunch of stuff right here that we need to simplify. What can I do with those negative exponents? Okay. There's a couple things that you could do, right? With these numbers, you might want to swap them, right? You might want to move this to the bottom and this to the top. You could do the same thing here, right? Move this to the bottom, this to the top. So let's do that. Again, don't blink. There's a lot going on. So this is 4 to the positive 2, b to the 3 to the positive 2. Everything that was on the bottom is now on the top. because everything on the bottom had a negative exponent. And then this is now negative 3, give me 1 second, to the positive 2, a to the 4th to the positive 2. Do we agree so far? Yeah? All right. And now this looks pretty easy to simplify, right? Not too bad. 4 squared is just 16. B to the 3rd to the 2nd, power to a power is b to the what? Good. Negative 3 to the 2nd is what? Positive 9, good. And then a to the 4th to the 2nd is a to the what? A to the 8th. There's nothing more we can do there, so this is our final answer. Was a lot, right? Kind of a lot to keep track of. Be super careful. Your steps might look different from mine. I think if you watch Mrs. Meadows' videos, I think she distributes the exponent right away. And then she simplifies that first. All right? If you want to try that for the next one, you can. I'm going to let you guys work on the next one. So work on your own first. Okay, couple things that you could do. The reason I like to simplify in the beginning is because a lot of you guys, when you distributed the exponents and tried to simplify it, got 729 over 27. Mind you, you're not using a calculator in this class until November. So can you guys do that by hand if you were timed on a 30-minute quiz with 10 other questions like this? No, probably not. So I like to simplify first. Try to take it piece by piece. What can we simplify first here that would make our calculation a little bit easier? The negative 3 and 9, right? You guys see what that becomes? Negative 1 and 3. X over x, what happens there?
They cancel out.
Cancel out. And then our negative exponents we can also take care of, right? We can move this to the bottom and this to the top. And then so what we have now is negative 1z to the first over 3y to the positive 2. And then we still have that negative 3 on the outside. That was one step, guys. Are you okay? Good. Again, I just simplified. Coefficient with the coefficient, x with the x, y with the y, z with the z. All right. So that's all I did. I'm just looking at the inside first. Don't worry about the negative 3 right now. But now that we did that, now let's worry about the negative 3. What can we do with that now? Distribute it to each factor on the top and on the bottom. All right, so then we get negative 1 to the negative 3, z to the first to the negative 3, over 3 to the negative 3, y to the second to the negative 3. And then we can simplify this as much as we can. There's nothing that we can really do with the numbers right now besides just switch them, right? We can see that this we can move to the bottom. This we can move to the top. Let's say you're looking at it right now and you see the power to a power and you want to multiply that first. You can multiply it first. Multiply, multiply. That's just a power to a power. So we have 3 to the power of 3, z to the negative 3, over negative 1 to the 3, because we switched it, and then it's going to be y to the negative 6. I kind of did two things at once there. Are we okay with that? Okay, we're still following along? Again, don't blink, guys. A lot of things happen. So 3 to the power of 3, we know that that's 27. What can I do with this z to the negative 3? Move it to the bottom, so I know that that's going to be z to the positive 3. All right, and then negative 1 to the positive 3, what does that get you? Negative 1. And then this y to the negative 6, what can I do with that? It's going to move to the top. This is going to become y to the positive 6. All right. Is there anything left to do here? No. It's fine like that. You can have the negative 1 there. That's fine. If you want to erase it. Oh, shoot. Hang on. If you want to erase it, that's perfectly fine as long as the negative doesn't disappear. That's another thing. It doesn't matter where the negative is. If you got negative 27, y to the 6, over z to the 3rd, that's also fine. That's equally correct. It doesn't matter if the negative is on the top, bottom, or on the outside like that. All right? As long as there's only one negative. But it should look like this, your final answer. Yeah, let me zoom out. So that's the whole problem. All right, so some of these questions are pretty easy. Some of them take a little bit more time. Am I going to make every single question like this on your quiz? Probably not. You'll get a good mix. Some of them are going to be slightly challenging. Some of them might be a little bit easier. You'll get a good mix. I can promise you that. All right, so just a reminder, quizzes next week, Wednesday. All right.